Hello, everyone. Today, I see you again today. Today we gonna review for the lesson you used to learn also. So we're gonna review about the radicals. Sometimes we call SIRS, and this you learn a little bit from last period in elective, in class AB elective. Okay. Again, one more time. This is this class for class 11AB core. Okay. This class is for 11AB core. And the topic today, the lesson today is operations with radicals. Radicals sometimes we call SIRS, like call kind of square rooting. Okay, so we're gonna learn only the operation mean addition, subtracting. This one have G. Okay, or and multiplying radicals. So we're gonna learn these three operations today first, and for the divisions, or sometimes we call quotient or kind and concerned about the powers, we're gonna do in maybe next class. Okay, but today we review for this thing first. First of all, we gonna review about the formula again. Just refresh our formula you guys used to learn before in previous years. Okay, so x power 1 over n you can write in this pattern become uh, square root n of x. Okay, and this one if you write in square root x y root n here, you're gonna break it down in this way. Okay, and also if this one square the x, they have the square root in two layers, right? You can swap power m n here to be n outside m inside, but actually this one means square root mn of x. Okay, and then this one x power m over n you can write in this way. So I think you get used to about this one already, or equal to this pattern you write down become the whole thing power m, can the same. And this one also, this also we can break it down. This is a whole thing square root n here, you can break it down become numerator and denominator separate in this pattern. Okay, these are the formula so far. Okay, you get used to already. Now next, this one more like algebra formulas. Okay, but they will relate it somehow when you do factor or like in some index. Okay, we concerned about the index here. So we're gonna learn this a little bit today, but I will bring more extra question about this one later. It's more like algebra thing. Okay. So the formula, this one everyone know, x squared minus y squared equal to x minus y times x plus y. And also x power 3 minus y power 3. This one power 3 also. Okay. So equal to, when this minus, this gonna minus also. Okay. And then plus. And if this one plus, this gonna be plus, and next term here gonna be minus. So in then next formula, this is called special product. Okay, so then this have x minus y, the whole thing power 3 will equal to x cubed minus 3x squared y plus 3xy squared minus y cubed. So then power 3, and then this one you observe when this minus, this gonna minus, and the last term minus. When they plus, the whole thing become plus and the rest the same. So it's really easy to remember. Okay. Now this all the formula, we refresh all the formula you learned in the previous years. So now we go, just see next gonna do, we're gonna take a look for examples. This is, we talk about plus subtract first. Oh, the one I load where they've gone to. Okay, sorry, it's here. I turned to the long page. Okay, now we go next page here. Now see this. Simplify the following expressions. This one you observe 3 times 6x cubic of 6x and plus 2 cubic of x and plus this one. This one you have to, the first step you have to find out which one's a like term or this one's this like term. or this different term. You can observe here this one, right? Qubit of 6x same as this one, right? Because they are same here. So then you can plus or subtract. But now this plus this 3, this is 1. So you have 4. So you have 4 and qubit root of 6x. Okay. And then again this term, okay, this one is like term also, the same term, right? Because you observe cube root of x and this one cube root of x. So this plus sign, they should sum it up. 2, 1 become 3 and cube root of x. So this is a final answer because now it's a different term, now cannot do anything much because they're different term. Even they have the same qubit root, but inside the variable and the here is a different. Okay. Of course, every time we check first, they're the same cube root. Yes. Okay. And inside here now is a subtract. So this one we can subtract yet because here, even though they have x force and y power 3 here. So the best way we have to do is try to simplify it first. Okay. Simplify it because 16 is, you can make it down become 4, right? 4, that means 2 times 2 and another 2 times 2. 2 times 2 times 2 times 2 times 2, right? So because of cube root, so you have to get the 3 same 2 here, take it out. So you have 2 here, take it out from the root. Okay. So now you left 2 here, right? So you're gonna have square root 2 underneath here. And x power 4, that means x times 4 times 4 times 4. So 4 terms. So you can get x out, 1x out. So you left 1x under root. Same idea. But y power 3, exactly square root 3 here, cube root. So you get y out the whole thing. So you left inside like a y power 0. So this is the first term. And then don't forget like cube here on the top. Okay. Then minus cube root like that first. Then see what you left. Do the same way. 54. 54 is what? 54 can do by, you can do short division, right? So you have 9, 6, 54, right? So this one you have 3, 2. So 9 is 3, 3, right? 9, 3, 3. So you can have same 3 or 1, 3 to take 1, 3 out here because cube root. So you have 3 here outside, you take it out here. So you left 2 and inside the root. Haven't taken it out yet. So x the same thing now. Power 4, you have 1x out. Right? You we left 1x inside and y power 3 in cube, so you take y out. Okay. So now you observe. Now this inside now is a same term, right? The cubic root of 2x and this one also cubic root of 2x. So they are the same term. So you can sum it up. But this one have to subtract because this one plus, this one minus. So we subtract this negative 2 plus 2xy, right? So we're going to have negative xy and the cube root of 2x. Okay, so this is going to be the final answer for this question. Okay. Any questions so far? We review only, okay? So maybe we can go a little bit faster if possible. Go next example. Okay. Now, talk about multiplication now. See, multiplication. Multiplications, see, square root 3a square times 6 square root 6a. This one you can see because they have square root the same, right? We can use the formula of what? Like a power n times b power n, right? Even base, that's different, but you can combine by a times b, right? And the whole thing power n. Because this the whole thing power 1/2, same thing if you convert, right? So you can just like in this pattern. So you can combine inside. If you are not used to, you can convert to be the power fraction first, right? Like a 3a to the whole thing power 1/2. Okay, but now this one we can combine because the same square root. Okay, so become 3a squared times 6a. Okay, so this is gonna be because 3 times 6, right? It's 18, but then 6 you can break it down become 3 times 2, correct? But because square root 3 and 3, you can get 1 3 out, right? You can get 3 out. You can get the 3 out first, right? I lay down here. So you left 2 inside under root here. But a power 2 times a become a cube, a power 3, but square root you take 1a out here. So you left 1a under root here. So the final answer gonna be 3a square root 2a. Okay. Now this one can use by this formula. The next one, multiplication also. Okay. You can see this multiplication with the same index, right? Because this is the same index, square root or power half 1/2. This one is what? Fourth root, right? Or if you can say the whole thing, power 1/4, and this one power 1/4. They have the same index. Same index, then you can combine this one to the same way, right? You can combine it. So you write down first, fourth cube. So you have x power 3/2 times x2 over 8. Okay, so this one gonna be we may not to time it up, say become x power 5 over 8 over 16, up to you. Okay, but now it's really the number here we can see really clear because fourth, right? So 8 is what? 3 times, it's a 2 power 3. So another 2 become 2 power 4. So it's enough, right? It's enough to take it out. So otherwise you can do this way, it's easier for you. You can write it down, become like this, right? Different. So become x power 5, right? If you want to time it up, over 16. We just try to refresh our in different of writing. Okay, if from here actually we can get the answer right away. If not, you can break it down according the formula we just learned. Okay, like a formula, this one, remember we just review from beginning, like a x over y. So you can write it down, become x root n over square root y root n. So this from this formula, okay, this one from this formula. So now from this one gonna be what the final answer. Because this is x power 5, but cube fourth root. So you take 1x out, right? And square root x. Okay. So over this one, because 16 is what? 16 means 4, 16. 4 break it down become 2, 2. So become 2 times 2 times 2 times 2. So you get the 2 out. And get the 2 out here. But don't forget this is a fourth root. Have to write down. Okay. So this is a final answer for this example. Okay. Now, more example. Right now is talk about multiplication also. Multiplications. See, cubic root of a times this whole thing. You just time this term times this, and this term times this. That's it. Okay. Because you observe, you can time or not. Yes, because the same cubic root. Okay, they're the same cubic root. Then you simplify cubic root times cubic root, so they become what? Okay, we write step by step. So that means a times a become a square, right? Minus, and then this one times this one. This one come from this one time, okay, time in. And then this one time in. Minus what? Cube root of a, and a square become a cube. So if you want, and then this you simplify it, become a square cube minus this one become what? A, right? Because a power 3 become a times a times a times a 3 times, so you can get one a out. Okay, this is a final answer. If question 1 you answer in the radical form or search form, you just leave in this one. Okay, or if question did not say radical, you can leave at a fraction power, correct? Like a 2 over 3 minus a. Either way. But now we do radical, so we're going to leave at the radical form. Okay, now we go next example. So far, everyone okay or not? Yes, sir, right? Okay. Now see next one. This one is multiplying radicals with different index or different powers. Okay, you can see. You can see this is a cubic root of 2 times cubic root. No, not cubic. This is a fourth root of 2. Okay, so in this case, you see if same base but different root. So we write in this power with a fraction, maybe easier to see. So we write that become 2 power 1 over 3 times 2 power 1 over 4, right? So now it's easy now, right, to see because this one become same base, different index. So we use the formula of a power n times a power m. So you have a power n plus m. Okay, so we use this formula. Now this one same base index plus. So you have 2 power 1 over 3 plus 1 over 4. Then you simplify it. Simplify the index. So 1 over 3 plus 1 over 4 become close, right? LCM is what? 12, correct? LCM means 3, 4. So you get denominator here. So 3, 1, 4. This is a short division. So 4, 1, 4. So your LCM is 3 times 4 times 1 times 1. So your LCM is 12. So 12, then you have to make your denominator equal to 12. Okay, so this one we do it on the power. Okay, so become 1 over 3 times make it 12, so times 4 over 4 plus 1 over 4 times 3, right? Time here, this one is less. I rewrite it. Become 1 over 4 times 3. Oh, times 3 again. Sorry. Okay. Over 3. So you have 4 over 12 plus 3 over 12. So you have 7 over 12. So now you have the answer to power 7 over 12. Okay, you can leave this one, but if the question want you answer in the rational form or search form, you have to convert to be 2 power 7 square root and then the index here. And then you simplify, right? Simplify to the final answer. 2, 7 is what? 2, 5, 32. 2, 6, 64. So 2, 7 become 1, 2, 8. Okay. So that is multiplication with different power. Okay, now we go next example. This one a little bit different now. A little bit hard. You have to do a little more step, not more step. You know what different here? The root. This the cube root. This square root, and base different. All different. This one still have the same base, but the power different. Correct. Now in this case, you have to do a little bit more step. Again, the best way we convert to the power with the fraction power first become 2 power 1 over 3, right? Time 3 power 1 over 2. Now this one can seem more clear. We cannot do anything until we have to do something else, make it equal to same power or same base. Okay, now how to do it? Again, we do the power here 103 and power 2 and 2. We find out, work in outside here and 102 here. Find LCM again. LCM is what, 6, right? So 6, that means you time, make it 6, so time 2, right? And this one become time 3. So you have 2 over 6. And this one gonna be 3 over 6. Now you move back to the questions, replace this one. So we write that become 2 power 2 over 6 times 3 over 6. Okay, and write in the third form. So become 2 power 2, 6 here, and time 3 power 3, 6 here. Now you observe it's same root now, right? This similar. Okay, this one, what formula we use? We use the, say if we have a power m times b power m, you can write it down become ab power m, correct? So this is, then now this is the same. Now we got the same 6 roots. So you can combine this one, can combine 6. And then 2 power 2 become 4, correct? Time 3 power 3, 27, right? So we have 27, correct? Okay. Now this equal to what? Become 4. This time it up become 108, right? Right. So this is a final answer. Any question for so far? Okay, so that's if we have like a base and the power different, then we have to find out the index, make the index equal, have the same root first, same root. Okay. Now, any questions so far? If not, we go next one. Okay. 5. Now multiplication, conjugate. I think this one really easy, right? You how to do, you do 2 times this and 2 times this every term. That's what we met already. We learned one time in elective class, right? Last period. And this one 3 square root 5 times 2, 3 square root 5 times negative 3 square root 5. So actually this one get from the formula a square minus b square. This one I think you recall, right? Become a minus b, and we talk about beginning a minus b, a plus b. You can factor it out. See, because if you time this one, the middle term will gone. You will left only 4, 2 times 2 become 4, minus, because this plus minus come up become 9 times 5 become 45. Okay, so Okay, so maybe we try here. This time this become 4. And this time this. Okay, so we have minus 6 root 5. And then this term times this. So we have plus 6 root 5. And then this one time become minus 9. 9 times 5 become 45. This one becomes 0, right? 1 minus 1 plus. So you have 4 minus 45. So you will left negative 41. Okay, so that's the final answer. So you can see this one is from this formula. Okay, so how we work on this formula, for example, if I give you, it's really important, okay, or the formula beginning when they talk about the first time at the beginning of this class. For example, if I say I have this one, let's see, if I have 2y squared minus 7, I want you factor this one by using radical. Radical, that means your final have to come with like a square root, something like this, right? The final answer. So how you factor this one? Okay, like this one, if I give you like a 25a square, maybe minus 4b square, you know how to factor, correct? But now 2 and 7, how we gonna factor? This one, if you factor, you have what? 5a, correct? And then this gonna be 2b, 1 minus 1 plus. Middle terms gone, 10, 5, 25a square. You check back, okay? And then this one 4. So when you check, you can check the middle term by this one time this one. For this one time, this one gonna be this one, right? Gonna be minus 10ab. And the further term here, this the last term, the first term and the last term of the second bracket, gonna be plus 10ab. So we sum it up. This one becomes 0. So that's why the middle term gone. You will get the answer. This one you can check it up. They will equal to this and this. Okay, but this one different. A little bit different because the two how we can factor it and save it. Do the same way. Use a search to help. This one you can do by. I think maybe everyone know already right with the answer. So 2, you square root 2. Right? Break it down, factor it up. Because root 2 times root 2 come out 2, right? And y outside the root, okay, become y. And 7, you can root it 7. And this one is 7. Now 1 minus 1 plus. So that's okay. So that's the answer. If you factor this one by using the radical, so your answer will have some square root like this to be the final answer with the radical sign. How about this one? 2x cubed minus 9. I want you factor this one by using the radical also. Okay. But this one maybe I go to the next space, okay, because I need more space. Oh, I load down here already. That's a finish already, okay. Now we come to this one. This one, the period example we did. But now if I have this one, if I have 2x cubed minus 3 power 2x power 3 minus 9, I want you factor by using radicals. This one how to do? You have to get the formula I give you at the beginning, right? X power 3 minus y cubed or so equal to x minus y and x squared plus xy plus y squared. Get this formula. How to factor? So see from here, how you this one this means power 3, so you divide by t, you left x power 1. So this do the same way, okay? 2, I like bigger here. bigger area here. So 2 power 1, so it's gonna be 2 1 over 3, right? Because you have x power 3, you have x power 1 here, so that means you have divided by 3. Why I know have to use this formula? Because this power cube power 3 here. Okay, but when this power 2, you can factor by use the formula of a square minus b square. Okay, now x power 3 here, you divide it by 3, you have x power 1. And because of this one minus, right? X minus, so this is a minus sign. And the y, 9, so 9 power 1, so become 9 power 1 over 3. Okay. So then this one, you see, right now you have x and y already, you break it down already. So use the formula, right now your x power 2, that means this one power 2. So you're gonna have this one 2 power 1 over 3 x power the whole thing power 2. I like this bracket. Okay. And then minus y, right? So it's the x square, this is the x minus y become x square plus xy. Plus xy, this means it's a x, this is a y. So you're gonna have 2 power 3, 2 power 1 over 3 times x. And this one gonna time 9 power 1 over 3. Okay. And the last term gonna be plus. It's a y, right? So you're gonna have 9 power 1 over 3 and the whole thing power 2. Okay. Everyone get it now? Because this one use a formula here, right? X minus y, you got here already. This is x. This term mean x minus y. This y mean this term. And then x squared plus x times y and plus y squared. Okay, now you can simplify and write it in the radical term or first term, right? So you can write it down, become 2 power 1, right? And square root, the cube root of 2 power 1 and x outside, okay? This is like bracket here. And minus 9 power 1, right? And this one cube root. And this one, you can write it down, become, because this one, okay, we write step by step. This one gonna be, if this one you write down, become 2, this is the power 2 you time in, right? Become 2 power 2 over 3 and x power 2 here. And this term gonna be 2 power cube x here. And this one times 9. Actually, this one you can write down right away if you want, right? Let me see, write down maybe easier. You can convert to be search form right away. Okay, then this one gonna be what? 2 power 1 cube. And this is the x. Time, this one 9 is what? Cube, right? And plus, this one 9 gonna be power 2 over 3 times it inside, okay? Now you simplify more steps to get a final answer. X outside minus 9 cube. And then this one you write at the search form gonna be 2 power 2. Can I change it right away become 4? Okay, save our time. Okay, now this one become 2 power 4 and 2 root cube and x power 2 outside plus this one root cube. You can time it up, right? The same root cube, right? So you can write down here root cube and 2 times 9 become 18 and then become x here and then this one plus become 81, right? Root cube. Okay, so that's your answer, but again this one you can write one more step because this one 81 is a 99 999, right? So you can get 3 out and this one can get or not cannot do anything, so this one can simplify x minus 9, this is the same, right? Plus this one because 81, so we can take 3 out, right? And cube 3, we let 3 and the root. Okay, so this one should be our final answer, right? Okay. Any questions? For this technique, I will bring more example, let you practice. Sometimes you can create your own question also, and you practice by yourself. By the way, you can have one bracket here. By the way, you can check your own answer. You can check by you expand it. From here, when you write it down here, right, you can check your answer is correct or incorrect. This one is a 9, okay? Not clear. So you can check your answer. You expand like this term time this, and this time this, and again this time this, and then second term of the first bracket time this, and this time this, and then this time this, and plus and sum it up. Plus minus sum it up. See, they will equal on the left hand side or not. If equal, that means we get the final answer here is correct. Okay. So any question? I think gonna be that's all for today, okay? And for your handout for this lesson, I did not give you follow every page. I mean every page of pages. I did not give you every page because I think you already learned from previous year. The main thing I want you to do is I give you exercise and to practice. And the exercise I give to you, this is very simple. Just refresh your memory. And after we finish review of this thing, we have extra question. This is harder a little bit and let you practice. That's the main thing I want to do. So now we just keep patient to review first, refresh out all the formula, all the thing we needed to for the next lessons, for the harder one. Okay, so that's for today. Thank you for watching this video, and please try to do my question also for the assignment. Try to do it and give me on time. Okay, give me by due date. Oh, by the way, please when you hand out your work, every time on your paper you must write your name, your class. Okay, your name and your class A, B, or class C something, and your name must be on your paper every time. Please don't forget. Okay, bye bye. That's it for today. Bye.